Welcome to ClickMyProject.com. Let we discuss about the process, automatic localization and segmentation of optical disc in fundus images using morphology and level set. Let me see the abstract of the process, automatic localization and segmentation of optical disc in fundus images using morphology and level set segmentation. Optical disc localization and segmentation are important in developing systems for automated diagnosis of various serious pathological pathologies. This process presents a vast robust methodology for automatic localization and segmentation of the optical disc in the fundus images. This method locates the optical disc with morphological approach based on the combination of the vessel convergence and intensity. The boundary of the optical disc is extracted by using distance regularized narrow band level set evaluation. This algorithm has been validated in different databases. The drive DRLSE algorithm identifies the defected portions in that is identifies the optical disc in the input images based on the identification of the brighter regions in the images and the removal of the blood vessels in the particular locations. Initially, the blood vessel regions were extracted from the background estimated green channel of the input retinal images. The green channel is selected because the green channel contains the information regarding the retinal images. From the detected regions, the uh, brighter intensity is obtained based on the identification of the pixel having maximum intensity, and we subtract some 10 to 20 pixels from the images, and the pixels between the particular ranges were extracted as the maximum luminous pixels, and the regions were used for the detection of the maximum size. Finally, the contours were extracted for the input images based on the level segmentation process. The detected regions From the detected regions, the performance of the process is measured in terms of the measuring of the accuracy, sensitivity, specificity, uh, F measure, area of the processes, and other values that were used as the performance metrics. The retinal images were obtained from the dataset. From the obtained retinal images, the green channel alone is extracted for the further processes. The green channel of the retinal images contains the most important information regarding the optical disc and the blood vessel regions in the input images, and hence they were extracted. After the extraction of the green channels, the background region is estimated from the retinal images in order to remove the excess unnecessary regions that were present in the retinal images. After the estimation of the background, blood vessel extraction is employed. The blood vessel extraction is employed based on morphological operations. The blood vessel extraction identifies the exact blood vessel locations in the input images, and hence the blood vessel regions were detected from the input images. After that, the fuzzy segmentation process and the morphological operation process were applied to the input blood vessel detected regions. The opening operation removes the unwanted blood vessel regions that is detected in the process, and the fuzzy segmentation segments the input images into the blood vessels and the non-blood vessels regions. These two were combined, producing a image which depicts the information regarding the blood vessels more exactly. And after that, the region of interest is chosen, which is identified based on the brighter regions from the input green channel images. The brighter intensity in the input images were obtained based on the identification of the maximum pixel in the input green channels, and we subtract some 10 pixels from it, and the pixels within that particular ranges were extracted from the input images. Finally, the performances of the processes were measured in terms of the performance matrices like accuracy, sensitivity, specificity, precision, F measure, and the area of the overall detected regions of the input images. Hence, we detect the blood vessel regions and the brighter pixels in the input images. Let us see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. Right click it and click on run file. You will get the process started. Select any one of the images which is present in the dataset. The process will now execute. All the results were displayed. This is the input image that we have selected. This is the green channel of the input image. Then the background regions estimated from the input image. From these images, we finally extract the blood vessel regions in the image based on the morphological operations. The opening of the detected blood vessel regions detects and removes the unnecessary blood vessel regions that is obtained in the input images. After that, the segmentation of the images were done based on the clustering process using the fuzzy clustering algorithm. Then these two images were combined to produce the resulting image. This is the combined image produced after the combination of the opening function and the fuzzy segmentation process, and this identifies the blood vessel regions and also the unnecessary portions of the input images. The brighter regions were then identified based on the identification of the maximum pixel in the input green channel, and the maximum pixel is subtracted from 10 or 20 so that we obtain the brighter regions in the input images more exactly. So these brighter parts were identified in the input images. This brighter region is superimposed to the original image. This is a superimposed to original image, and in that outer contour is drawn in the input images. Hence we have identified the blood vessel regions in the input images, and we have detected the brighter portions in the input images, and the contour is extracted around the images. Finally, the performance of the process is measured in terms of accuracy, sensitivity, specificity, F measure, precision, and the area value of the input and resulting segmented regions and the ground truth images. From the values extracted, we can see that the proposed system is capable of the identification of the um, these blood vessel regions and the brighter portions in the retinal images more effectively compared to the other existing methods. So this process is done based on mainly morphological operations and thresholding processes. Uh, the segmentation of the blood vessel regions and the brighter portions of the input retinal images is done based on the DCUT process and the morphological and thresholding process. Thank you.